Hey guys. Okay. Why? I don't know why my audio was peeking out there for a second there. But welcome to Confusing Bits. I'm Corey, and today we're going to talk about Accelerate, building and scaling high-performing technology organizations. Okay, so before we get into this is it's going to be talking about software development, obviously. So if you're just here for my general book reviews and you're not into software engineering, maybe you can skip this one, right? But the too long didn't read, too long didn't watch is it's okay, but it's on shady statistical footing. Like, we're dealing with human behavior, and this is a study of human behavior. So if you've been following along, you know my opinion of most studies of human behavior is unreliable. So, but they talk about some interesting things. So with that said, let's dig in. The Science of Lean Software and DevOps Accelerate, Building and Scaling High-Performance Technology in Organization by Nicole Forsgren, PhD, Jez Humble, and Gene Kim. I want to be clear, they definitely caveat, they go through all the song and dance of caveating all of this stuff, but I don't know if you ever seen some of the YouTube's people quoting this book or referring this book. There's Dave Farley, his continuous deployment, continuous delivery YouTube channel. He quotes this book all the time like it's gospel. And whether or not you agree with his opinions or not, I don't think that citing this book is as strong evidence as he seems to imply in his thing. But he's actually the one who highlighted this book for me, and that's why I got it here. This got forewords by Martin Fowler and Courtney Crisser, and a case study contributed by Steve Bell and Kara Whitney Bell. So, all right, let's do the blurb on this. Accelerate your organization to win in the marketplace. How can we apply technology to drive business value? For years, we've been told that the performance of software delivery teams doesn't matter, that it can't provide a competitive advantage to our companies. Through 4 years of rigorous research, including data collected from the State of DevOps report concocted by Puppet, Dr. Nicole Forsgren, Jez Humble, and Gene Kim set out to find a way to measure software delivered performance and what drives it using rigorous statistical methods. The results are groundbreaking. Observational data representing both the findings and the science behind Dr. Forsgren, Humble, and Kim's research. Accelerate allows technology managers at every level to see, evaluate, and use successful applications to elevate their own organizations. Discover how to measure the performance of your teams and what capabilities to invest in and to derive higher performance. And some of the blurbs, the quotes here, a must read in a sea of books about technology approaches. Accelerate stands out in its clarity and practicality. It's by Karen Martin, author of Clarity First, the Outstanding Organization. Excellent, as well as conclusively showing that DevOps outcomes are faster, cheaper, and safer. This book is an excellent case study for robust survey design and analysis. Adrian Cockcroft. I don't know who that is. We strongly recommend this book to anyone involved in digital transformation for solid guidance about what works, what doesn't, and what doesn't matter. Tom Poppendieck and Mary Poppendieck, authors of the Lean Software Development series of books. So a lot of people are just hanging there. This is kind of goes on to my ongoing thing of the raw science thing, where people think that just because there's a study that it makes it study in scientific journals or whatever makes it somehow robust. Just because something made it through peer review doesn't mean that it's a fact. It's what they've observed, what these authors have observed, and what they've chosen to report on. So doesn't mean it's true or not. Science is a process. It's not a series of facts. This is just one data point, right? So anyway, the book is, as I mentioned, there was some surveys that apparently Puppet put out. Puppet is a testing framework, a browser testing framework. I'm guessing that's the Puppet that they mean. And they analyzed some data set from there. So we're looking at survey data first and foremost. So you're getting really there's a bunch of caveats with survey data. It's self-reported. There might be some bias in the reporting. There might be bias in the questionnaires, bias in the data based off of the types of questions, the way the questions are phrased. And again, we're dealing with human behavior, so there's no controls. There's not a whole lot. All we can do is association. The only thing that this talks about is association. Associations are not causation. Let's say that again. Associations are not causation. Until you do a statistically valid controlled trial on these methods, you cannot prove causation. You cannot prove that these methods cause this outcome or is associated. All you can do is associate. I'll tell you what, go to if you don't believe me, pause the video and go to type in Google thing, just type in spurious correlations. Your top result will probably be this web page, and you click on it, and you're going to see all these graphs of like random stuff, like the taxi car drivers versus number of eggs eating, taxi car accidents versus number of eggs eaten in a day. Just these random associations. That's going to happen in any big enough data set with enough outcomes. You're going to get correlations by chance, just by complete chance. That doesn't mean that one causes the other. And it doesn't tell you if which one caused the other. Even if there is an association and it is real, you don't know which way the causation goes because you haven't done a test. A big example is like the association between car accidents and ambulance calls, right? Like which one causes which? Well, we know from our evidence, but you could just looking at the data, unless you have the context, you don't know which one causes which, right? So anyway, there's all sorts of spurious correlations. It's a known thing. I'm not making it up here. This is observational data. Observational data cannot prove causation. No way, shape, or form can observational data prove causation. With that said, what did they find? So they talked about they were looking between they were trying to figure out which software teams were performing better, meaning they had less defects, that they were delivering more features, that they were that it cost less. The number of different ways that they were trying to figure out, and they come up on a few metrics. And let me find the actual ones again. I should have it ready. Okay, so they come up on a couple of relatively objective measures. They look at deployment frequency, lead time for changes, mean time to failure restoration, I can't remember the exact word, and then change failure rate. So deployment frequency, how many times are you deploying? And lead time for changes, how long from the first commit, how long does it take from ideation to deployment, to deploying the feature? How long does that take? And then the mean time to restore. So if there is an error, how long does it take you to fix the error? And then the change failure rate, how often are you introducing bugs? And they found, long story short, is that if you deploy a lot, all of those metrics go down. That if you deploy it, all those code quality things get better. So if you deploy a lot, then you're going to have less lead time to change. You're also going to have less mean time to restore. So if you do have a failure, then you're going to restore the failure quicker, and you're going to have interestingly enough, less change failure rates. When you think about it, if you're deploying every 6 months, every deployment is going to be super risky because you're going to have a bunch of changes, a bunch of things will have changed between this version and the new version. And it's going to be a scary ordeal, right? And so you take 6 months and you do a bunch of testing. You have this huge QA staff. You're doing all these unit tests and you're running everything. And it takes 5 hours to validate a new build, just an automated test week. It takes a week to make it through QA. You've got these long processes that take forever. That's why you have a 6-month deployment rate, because your process is not fast. But if you go flip it on the head, like every time a developer makes a commit and it runs tests to validate that commit, and then that gets deployed to some version, at least to a dev, or ideally it goes right to production, because that incentivizes the developers to always be writing tests, to always be developing features in backward compatible ways. And if they're an hour away from production deployment, then they're an hour away from fixing a deployment failure, a production failure, right? So, and you're only doing these one change. So if something fails, the last thing that you did broke something, so where the problem is, and you can either just revert to an older version, or you can push out a new fix, whichever one's most appropriate, within an hour. So waiting doesn't get you, this is my opinion, waiting doesn't really save you anything. You're just going to add a bunch of extra process to the thing to try and protect you from it's like, persons looking to become a writer or whatever, and they're so afraid of making mistakes, of not writing good things, that they never ever publish what they write. They just keep waiting. They wait till they're perfectionists, and they never get it done, and they never get it published. Versus an author that says, okay, I'm going to have a day to write this new short story, and then I'm going to publish it. And then the next day, they're going to publish another one. And the next day, they're going to publish another one. Which one is going to be a better writer after 6 months, after a year, after 10 years? Obviously, the one who's publishing a story every single day is going to be a way better writer than the guy who never publishes, or only publishes like once a year. It's just, that's how skills work, right? Same thing with your deployment skills. If you're not practicing deployment, if you're not practicing testing, if you're not practicing error handling, if you're not practicing outage handling, or bug fixing, if you're not practicing fast iterations on that, you're not going to get fast at it. You're never going to. You have to run the race to get better at the race. So anyway, that's pretty much the book. I am glossing it over. They go through a bunch of, there's bunches of little pretty graphs in here, and all sorts of citing statistical things, and they talk about questionnaires and all sorts of stuff. And I will say one thing about the book. They do talk about the statistical methods and everything, and where the data and their analysis methods. And it's very much kind of an expanded peer review paper kind of thing. I don't know if this was the publication or if it's based off of their research. I think the whole book is the peer review, but anyway, is the peer reviewed publication. But yeah, this book emerged from the partnership between Dora and the Puppet on the state of the DevOps. So thus we'd like to start by thanking the Puppet team in particular, blah 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 blah. Yeah, so this is the peer reviewed publication, for more or less. But this is very managerial. Let's put it that way. This is talking about. This is the type of stuff. This is corpo speak kind of stuff, right? This is talking about stuff in a way that nobody talks about things, right? Unless you're in that corpo proper speak kind of mode, you know, where they're talking about employee satisfaction and team experimentation and shifting left on security. That right there, shifting left on security, and all sorts of weird, you know, was it convergent variability and measuring and changing culture, modeling and measuring culture, and it's got tips for, it's like a whole thing for leaders and managers. So it's got the executive summary in here. So it's very much targeted at selling a particular way of developing to management. This book is really more targeted at management, and I'm assuming that the management doesn't is not very scientifically literate, because this is making a bunch of artists that I agree with, that you need to be deploying more frequently, and this whole idea of where not everybody's Google. Like, here's the thing, I do contract development, and it's mostly for startups or small companies. We're building small applications for them, mostly small applications. We're talking like maybe 100,000 lines of code, that kind of on that order. Not super complex development, but usually it's greenfield development in MVP. And the thing that I always try to drive home is that it's better to just be deploying all the time. We've had clients in the past where you couldn't deploy to their production without jumping through a bunch of hoops, and you had to get like on a call with them, and then we had to take the old system down, and then we had this really painful deployment process every time we go to production. In that project, you'd say almost was a failure, you know, maybe even call it a failure, because you just couldn't deploy any changes, and they were so afraid of things breaking, and because they were worried. The problem was they were I don't know the solution to this. So like the client was worried about things breaking and then us not being able to get a fix out to them. And the reason why they had the fear of things breaking in the past, because they would get a bunch of calls about things being broken, because this was the customer support people, and I'm like, well, things are going to be breaking. There's things broken that you don't know about right now that somebody could call like an immediate. So the if it takes us an hour, if it takes us 6 months to get a new deployment out, that means that they got to stick with the bugs for 6 months. If it takes us an hour to get a new deployment out, then we can get the fix out in an hour, or on that order, right? And we just couldn't get that across to the client, and so that's part of the issues to deal with. But like, and even then, even in our properly set up projects, a lot of times some of our teams are set up to where we have multiple environments. So we have a dev, and then we have a staging, and then we have a production. And my opinion has always been, let's just push to production. We have our local development machines to just push to production, especially in early stages, like MVP stages. Let's just push to production. Like, just keep pushing. Like, we're only going to be an hour or two away from a bug fix. It's not that big of a deal. It's MVP. They don't have any users, that kind of thing. So we're adding all this headache, and even when they do get users, it still applies. All that means is that we just need to add more testing. Once we go into production, that means we start adding more and more tests. At least that's been my opinion. And it's, I will cite this book. This book says we need to deploy more, and not to We need to deploy to actual users, not just to dev, not just to staging, but we need to be deploying more frequently to production. And so that's what the book is saying. Again, it's an association. I could cite my own experience, but so can other people. Talk about how the nightmares of breaking production, and then the alarm bells are going off and management is screaming, and maybe that's their experience, but anyway. So yeah, this is the core cited book for like any time you start talking about CI/CD, and in particular trunk-based development, where you only have one main branch, and you're only like all the commits go into the trunk. You don't do the weird version. See, all the stuff that I do is on the web, so there's no point in having multiple versions on the web because it's a single line of commits. I'm not gonna make a commit to dev and then port that commit to staging and then port that commit to production. We don't do patches. We just push everything, and our patches are just one single commit. Everybody gets the same commits, and it's so much easier to manage it that way, at least in my opinion. But anyway, we're getting off the topic. But yeah, they talk about trunk-based development as well. So that's part of this as well. So again, maybe I'll cite this, that yeah, we should be doing trunk-based development, and anything else is just adding friction to a process. And like, things are going to break. It doesn't matter how much processes we put in. It doesn't matter how many tests we put in. Things are going to break. So what we need to do is optimizing for fixing those breaks. We fix the bugs, optimize for fixing the bugs. We are optimizing by optimizing to fixing. If we optimize for fixing bugs, we're also optimizing deployment frequency. We're also reducing the overhead of each deployment. Because if you add a whole bunch of process, there is no world where adding more process is going to be safer or more efficient. Adding things to a process is always going to make things more expensive and more error prone. That's just how things work. So anyway, that's I think I said my spiel, and we're already 20 minutes in. So anyway, this has been Accelerate, the science of lean software and DevOps, building and scaling high performance technology organizations. So that's that. Next up, I guess I'm going to do Sam Harris's Waking Up, A Guide to Spirituality Without Religion. It's about meditation. Anyway, without the woo-woo. All right, yeah, I'll see you guys next time.